Hi guys. Sorry I'm not with you today. So hopefully before we start this, the class will have presented all the parent graphs that you did on Wednesday. So hopefully that took about 20 minutes to present all those, and hopefully you took notes. And I'm going to help you with this first worksheet. Okay, I know it's a review of what we did last year, but you did do this for a while last year, and so hopefully by going over this with you, it'll help bring back memories of parent graphs. Okay, so has everyone got this out? Here we go. So this first equation of the parent graph is p of x equals x squared. This is quadratic, right? Does everyone know what quadratic looks like? It's a U. Okay, so if you look at your notes, you should have 5 key points. Or look at someone's parent graph at the board. Find the quadratic one. There's 5 key points on this one. Okay, they're actually right here. They're already graphed. This is the graph of the parent graph, these 5 points, okay? We're going to draw a new one. We're going to transform it. And they want us to do that by doing a vertical stretch of 3 up 2 units. So how would the equation transform? So anytime you change it, you're supposed to call it, so right now this one is p of x. So let's just call it a different, let's call it q of x. So we're going to first vertical stretch it by 3. That means you're going to multiply on the outside of the quadratic. Outside. That's what a vertical stretch of 3 looks like. Up to means no parentheses. It goes on the outside. You add it to the x squared term. And this is what up to looks like. And that's your equation. Now, how would we graph this? Well, a vertical stretch of 3 means instead of going over 1, up 1, you would go over 1, up 3. So this first point right here would go here. This one was up 4 already, so if you went over 2, up 4, instead of going over 2, up 4, you would go over 2, up 12. It's 4 times 3. So I think we're just going to concentrate on this first one. And then another additional 2 up from that. Okay, so what I would do is maybe do 2 t-tables. Okay, so our original t-table is -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. That's the original 5 points. If you look at the quadratics on the board, that's what you would see. So if you just did this just did the vertical stretch, that means all the x's would stay the same, but you're multiplying all these by 3. So it's 12, 3, 0, 3, 12. And then the additional 2 means you keep the x's the same, but you add 2 to all of these. Add 2, add 2, add 2, add 2. So the only 3 that I can actually fit on the graph are these 3. So originally it was over 1, up 1. Multiply that by 3, so you're going to go over 1, up 3, and then an additional 2. So it's -1, 5. Like, you don't have to do the t-tables if you just kind of do it in steps. 0, 2 is up here. We moved it up 2 and 1, 5. So the new graph looks like that, and we're going to call that q of x. What's the domain and range of the transformed data? Gosh, do we really want to do this? Yes, we do. Domain. How far left does it go? How far right does it go? It goes left forever and right forever. So your domain is all real numbers. The range is how low and high it goes. Low to high. The lowest it goes is right here to 2. The highest it goes is to infinity. You guys remember doing interval notation? Or you could say all the x's greater than or equal to 2. You could do set notation, all the x's such that all the x's are greater. Oh, you know what? That's y's. That's range. Sorry about that. All the y's such that y is greater than or equal to 2. I just prefer this. Sorry. Okay. What is this one called? Talk about it. Talk about it. It is the cubic function. You guys find it? Find it on the board. Find it in your notes. What does the cubic graph look like? It means that if you had -2, it would be -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So what's different about this one and the squares are all the y's were positive because squaring something makes it positive. But a cube, if you cube a negative, it still is negative. So you can have some negative y's and some positive y's. All right, now they're not telling us, they're not describing what they are this time. This time they gave us the equation. So what does this do? If it's on the outside and there's no parentheses, it's a reflection over the x-axis. That's number one. The second one is up 3 units. So the reflection part, what does that do? If a reflection of the x-axis means instead of 1, 1, you would have 1, -1, so you would change the y. So the very first t-table, we'd go -2, change the y's to their opposite. Change the y's to their opposite. See how all the y's now are their opposite? That's the reflection part, and then up 3. Up 3 would be add 3 to 8, add 3 to 1, add 3 to 0, add 3 to -1, add 3 to -8. These are your final points. So which ones do we want to graph? Let's graph the 3 in the middle. So we would get -1, 4, 0, 3, and 2, -5. That doesn't seem right. Oh, sorry, 1, 2. Whoops, there it is. 1, there it is. With a cubic, you always have 3 points right in a row. Like, look at the very first graph. These 3 points, -1, -1, 0, 0, and 1, 1, I call them the 3 amigos. And then you just kind of just like whip around it like that. So when you do a reflection, it's going to be whipped around the other way, like this. Like that. But there's always going to be 3 points that it kind of whips around. Okay. Shh, my dog's here with me. You guys want to see my dog? She needs a grooming. Look at her. She needs a grooming. She's barking because she wants to go home. Okay. So what is the domain and range? How far left does it go? We could say it goes to -infinity. Oh, actually, it's going to positive infinity. On the left, it's going to positive infinity. On the right, wait a minute, let's think about this. I'm sorry. I'm so tired. Domain. On the left, it's going to -infinity. It's going left, 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 left. On the right, it's going to positive infinity. The range, how low does it go? It's going pretty low, right? It's going to -infinity. How high does it go? Positive infinity. That's your domain. So pretty much cubics, it's always all real numbers for both. Okay, look at your parent functions on the board. What's this called? Some people call it the radical function. Some people call it the square root function. They're both right. So on this one, if I plug a -4 in, for example, into this, I cannot take the square root of -4. So there are no negatives on a t-table here. It's going to be 0. What's the square root of 0? 0. What's the square root of 1? 1. Now I wouldn't put a 2 in, I'd put a 4 in. The square root of 4 is 2. So that's the 3 points that you're seeing right here. 0, 0, 1, 1, and 4, 2. Can you think of what the next point would be? The next one would be 9, what? 3, you're right. 5, 6, 7, 8, 9, 1, 2, 3. The next one's going to be right there. The next one would be 16 and 4. They're the square roots. Shh. Shh. She doesn't like, Snowball does not like square root functions. So we're going to go left 5. Shh. Snowball, quit barking. Come here. Come here. So left 5, down 3. So we're going to go left 5. Let's graph it first and then write the equation. So left 5, down 3. Whenever there's like lefts and downs, you can just do it right away. Starting at 0, 0. Let's go left 5, 1, 2, 3, 4, 5, down 3. That's where your new point's going to start. Next point, go to your second point, the 1, 1, 1. Go left 5, 1, 2, 3, 4, 5, down 3. This point, go left 5. Right now it's at 2, 4. So if you go left 5, you'll be here, down 1, 2, 3. So this is your new graph. So how do you write that equation? Let's call it Q of X again. Left 5. So I'm going to do a square root. When you go left or right, because that changes the X, you have to put inside the function the 5. But you write with the opposite sign. So it's going to be X. If you go left 5, you're going to have plus 5. So if it says left, you do plus. If it says right, you do negative. Look at the little hint sheet I gave you. Down 3 is going to go on the outside of this. It's going to go outside of the radical like that, and that's your equation. So what is the domain of this? How far left does this go? It looks like it goes to 1, 2, 3, 4, 5. As far as it goes is negative 5. So your domain looks like it starts at negative 5 and it goes to positive infinity. From negative 5 to positive infinity. Range, how low does it go? Well, it looks like it goes as low as negative 3. And it goes up to positive infinity. What do you notice about negative 5 and negative 3? That's the ordered pair of the starting point. Do you guys notice that? So we have another quadratic. So this is a quadratic, and this last one's a quadratic. So it says vertical shrink of 1/3. That goes on the outside and then up 2. So it's going to be Q of X. Vertical shrink is going to be 1/3 X squared up 2. So instead of going over 1 up 1, we're going to shrink this up 1 by 1/3. So instead of going over 1 up 1, we're going to go over 1 up 1/3. And then from that 1/3, we're going to go up 2. So it was here. And I go up 2. 1, 2. It's going right there. This one right here was over 2 up 4. What's 1/3 of 4? 4/3, which is 1 1/3. So instead of going over 2 up 4, you're going to go over 2 up 1 1/3. Okay, does that make sense? No. Oh, yeah. Go over. Okay, so 1/3 of 4, 1/3 of this, if you break this into thirds, is 1 1/3, which is about right there. But then you're going to go up 2 from there. 1, 2. So it's like right. Gosh, it doesn't seem like that's right. Oh, I know why. I haven't moved this one up yet. This one started at 0, so 1/3 of 0 is 0, but then you go up 2. So it's right there. So I'm just going to do some symmetry here for the other ones. And probably looks like this. Try it on the graphing calculator and see if that's what it looks like. Your domain, how far left does it go? Negative infinity to infinity. Range, it looks like the lowest it goes is 2. The highest it goes is infinity. You guys got the swing of this? Okay, look at your graphs at the board. What does this one look like? Absolute value of X. You're right. This is an absolute value. Now, absolute value, if you look at the t-table on the board, if you plug a negative 2 into an absolute value, it comes out a positive. Plug a negative 1, it comes out positive. So it's kind of like the quadratic, but it's not, like the quadratic is negative 2, 4, so it doesn't go up quite as far. 2, 2. Basically, the slope is 1. Okay? So this is what it looks like. Over 1, up 1, over 2, up 2. So if you go over 3, you should go up 3. Right 4, up 4. They should be the same. Left 1, down 1, because the slope is 1. So this is what the general, this is P of X. This is what they want us to do. So what does this, okay, there's actually 3 transformations here. What's this one? It's on the outside. So you're going to reflect over the x-axis. Let me show you what this looks like if you just do it with a pencil. So if I reflected this with just the first one, reflection over the x-axis, this is what my graph would look like. If I just had the negative, I would have this. Do you guys see that? Upside down V? Can you guys see that? That's just the negative. Now putting a 2 in there means that if I did a vertical stretch first, sometimes you can do the vertical stretch first and go over 1, up 2, then reflect it, then you would have been down 2. So instead of going over 1, so then it's here. So over 1, up 2, but then reflect it. So it's a little bit skinnier. That's the negative 2. So we have two things here. We have a reflection of the x-axis, and we have a vertical stretch of 2. It doesn't matter which one you do first. Reflect, then stretch, or stretch, then reflect. And the last thing is go down 1. So from here, from these points right here, go down 1. So this point right here, it's going to go down 1. This one's going to go down 1. This one's going to go down 1. And that's your graph. Domain goes left forever and right forever. We'll talk about that more in class. Range, how low does it go? It looks like it's going down low forever. How high does it go? It looks like it goes up to -1. Now, when you get to a point, you use brackets. Whenever you have arrows, you always use parentheses because it's open to some great number that we can't even think of. What's this called? We've already done one of them. Cubic. It's not cube root, it's cubic. It means the numbers are getting bigger by a cube of 3. All right, so the regular t-table of that is -2, -8, -1, -1, 0, 0. We've already done this one. What would you do if it says go right 3, up 1? So this is the original. So take this point right here. I want to say there's 3 points. I always say there's 3 amigos. Those are the 3 points that you're moving. So you're going to move these points. Right 3, up 1. Move this one. Right 3, up 1. Right 3, up 1. The 3 amigos. That's the new graph. So how would you write it? Q of x. Right 3 means it goes in parentheses, but because it says right, you're going to go -3 cubed and then up 1. Domain. How far left does this go? This not only is this arrow going down, but it's also going left. So that's -infinity. Not only is this arrow going up, but it's also going right. That's +infinity. And the range is also the same thing because it's cubic. This is the square root function or the radical function. That's what it looks like. Okay, that's the parent. So this is the transformation. So what is this 2 telling us? Vertical stretch by a factor of 2. It's also telling us 3 where. Is that left, up, what? Since it's inside. If it's inside, it goes left or right. If it's a plus, you go the opposite. So it's going to be 3 to the left. So a vertical stretch by a factor of 2 means, if you were plugging in x in, I would actually do the 3 first. So I'm going to go 3 left first. I'm going to do it with a pencil. I'm going to do 3 left first. 1, 2, 3. 1, 2, 3. 1, 2, 3. If I plug the x in, the first thing I would do is the 3. Then from here, so that's what it looks like. And then from there, I'm doing a vertical stretch of 2. So instead of going over 1, up 1, I'm going to go over 1, up 2. Instead of going over 4, up 2, I'm going to go over 4, up 4 because I'm stretching it by 2. So it looks like that. I'm going to get rid of the first one. So your graph looks like that. Your domain goes left. How far left does it go? It actually stops. It actually goes from -3 to infinity. Think about that. Range. How low does it go? 0. Up to infinity. That's actually the ordered pair of the starting number. All right. Last one. Absolute value. This is the second time. Each one of these got to go twice. It's a V. There it is. That's the parent graph. Over 1, up 1, over 2, up 2, over 3, up 3. A vertical shrink of 1/2 means that there's going to be a 1/2 on the outside, like this. It's going to reflect over the x-axis, so I don't have enough room, so I have to rewrite this. Reflection of x-axis means put a negative on the outside of the 1/2. And then add 3. That goes outside. So how would we graph this? If I was plugging in x, I would do this first. Then I would multiply by -1/2, and I'm going to add 3 less. So I'm going to do the reflection, then the vertical shrink, and then I'm going to add 3. So the reflection. Here's the reflection. You guys with me on the reflection? So the negative then, by 1/2. So instead of going over 1, down 1, you're going to go over 1, down 1/2. Instead of going over 2, down 2, you're going to go over 2, down 1. Half of that. So half of those original. So over 1, down 1/2 instead of 1. Over 1, down 1/2. And then over 2, down 1. Half of what it was originally. So it got a little bit wider. And then from here, you're going to go up 3. So from here, each of these points, you're going to go up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, something's wrong. I meant 1, 2, 3. This one right here. 1, 2. This one's, oh, this is at 1/2. I meant 1, 2 is at 1/2. Whoops. So they're so close together, it's hard to tell. So that would be your graph. The one in the red is your answer. So your domain is how far left does it go? Right? Range, how low does it go? -infinity. How high does it go? 3. Is that 3? 1, 2, 3. 3. Bracket. All right. So let the graph of f of x be the following. I know it's a weird graph, but these ordered pairs are really important. Okay? So I'm going to actually try to organize these ordered pairs. You got -3, 0, -2, -1, -1, 0, 0, 2, 1, 4, and 2, -2. Okay, those are the ordered pairs. It says graph each of the following. Take this function and move everything, what? Since it's not in the parentheses, it's outside, this is down 3. Take each one of these and go down 3. Down 3 means you're changing all these y's by 3. So I want to use the same x's. Down 3 means I want to subtract 3 from all those y's up there. I subtracted 3 from all of those, and I wrote them here. So it means that you're going to go -3, -3, -2, -4, -1, -3, 0, -1, 1, 1, 2, -5. And you're going to try to graph it the same way you saw the one up there. And it kind of got like that. It's the same shape. You just moved everything down 3. So what does the +1 inside parentheses do? Hopefully you're saying go left 1. So from the original graph, you're going to change all the x's by going left 1. So now we're going to go -4, -3, -2, -1, 0, and 1. All of these, but down 1. Shh. Keep your... Snowball, stop. So basically, this point was -3, 0. Now it's going to be -4, 0. See that? I have it right there. This one was -2, -1. So if I moved it left 1, it would be -3, -1. But I already have it in the t-table. So I think, personally, it might be a little easier to do the t-table because I think it's quicker than trying to figure out what these are one by one. I'm just looking at my t-table. I'm going to go ahead and graph it. And it looks like that. This one's tricky. We haven't had this one yet. If the negative is on the inside of the parentheses, but it's multiplied to x. If it's on the outside, it's a vertical stretch, but if it's on the inside, it's a horizontal. It's something that has something to do with horizontal. So if it's on the outside, I'm sorry, if the negative's on the outside, it's a reflection of the x-axis. If it's on the inside, it's a reflection over the y-axis. Reflect over the y-axis. Do you guys know that if you reflect something over the y-axis, so it was at 1, 4, it would be at -1, 4 over the y-axis. So you're actually changing the axis. So from the original, A reflection over the y-axis means change all of the x's to their opposite. But then this one says down 2. That one means you're going to change all the y's by subtracting 2. So we're going to do 2 switches. First thing we're going to do is we're going to reflect it over the y-axis. That means we're going to change all of those original x's to their opposite. So it's going to be 3, 2, 1, 0, negative 1, negative 2. Look at the original. And then I changed all those to the opposite. That's what a reflection of the y-axis is. The second transformation is down 2. That's what that is. That's on the outside. That means you're going to take all the original y's and you're going to subtract 2. So 0 minus 2, negative 2. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 2 negative 2 is 0. 4 negative 2 is 2. Negative 2 minus 2 is negative 4. And these are your points that you're going to graph at the end. So you got 3, negative 2. 2, negative 3. 1, negative 2. 0, 0, negative 1, 2. And negative 2, negative 4. So it kind of looks like the other one, but it's just going the opposite. So it's the curves over here and the points here, but now the curves over here and the points on this side because it reflected over the y-axis. Do you guys understand? That was supposed to be a little fun thing. I know you guys are getting tired, but we're going to move on here. Matching. So if you have a number on the outside and it's bigger than 1, it is called a vertical stretch. D. Done. What happens if the A is on the outside, but it's less than 1? If it's less than 1, it's still called vertical because it's still on the outside, but it's going to be a vertical. I can't find it. Oh, I was looking for shrink, but the word shrink's not there. Compression and shrink are the same thing. So it is E. It's a vertical shrink or vertical compression. Compression means get smaller. Now what happens if it's on the inside with the parentheses? Anytime it's in the inside, it has something to do with horizontal, the word horizontal. If B is greater than 1, this is different though. If it's on the inside, you do the opposite of what you think. So if it's a bigger number than 1, like a 2, you would not say horizontal stretch. You're actually going to say horizontal shrink. So I'm going to give you an example. If I said y equals 2x squared. Oh, that's not what I'm thinking. Something like, let me do a radical. What if I had this? If the 2's on the inside, you use the word horizontal because it's in the inside. But it's not a stretch, even though it looks big. If it's in the inside, you do opposite. So the opposite means you take the reciprocal of that, 1/2. It would be a horizontal compression by a factor of 1/2. You go the opposite or inverse of what you're thinking. Instead of multiplying by 2, if it's in the inside, you really are going to take the compression of 1/2. So anyway, this one's a horizontal compression. It's a hard one to remember on those inside ones that you're multiplying, but think reciprocal. Always think reciprocal. This one is A. Now, it's on the inside again, but it's saying it's less than 1. So let me give you another example. So what if you had a 1/2 in front of here? So what's the reciprocal of 1/2? It is 2. So it is a horizontal stretch because now that 2 just got bigger than 1. So now it's a stretch. So it's a horizontal stretch. It's F. This one's on the inside. Inside. Inside always means horizontal. Opposite. So instead of if you think negative means left, you're wrong because it's on the inside. So you got to think the opposite. So if you see a negative, you're actually going positive. So this one's going to be, what's left? I already used this. Wait a minute. I've used E, I used F, and I've used A. This is it's inside. So it doesn't say left or right, so there's only one choice. Horizontal translation is H. It didn't say left or right, but it would be a horizontal translation to the right because of the negative. Now this one is not in the parentheses. Anytime it's not in the parentheses, you always use the word vertical. If it's not in the parentheses, you use vertical. So what's left? I see a vertical translation. It would be a vertical translation up D units, if you want to be specific. Now, negatives. If it's on the outside, it's a reflection over the x-axis. That's B. That means you're changing the y. If it's on the inside, it's a reflection over the y-axis, which is G. And those you're matching. That was supposed to be everything you learned last year. You might want to study those. Try them again. White them out and see if you can get them right the second time. You might just happen to have that on the next test. Oh, we're done. 30 minutes.